All right, good afternoon. Thank you for coming. My name is Scott Wells. I'm the chief architect at Zilliant. Zilliant is a software as a service company that provides science-based price optimization and opportunity optimization software. And what I plan to talk about today is our journey effectively rebooting our product line from a more traditional on-premise or hosted enterprise model into software as a service, with Force.com as a key component of that. And some of the challenges we had incorporating that into our existing processes, or even some of the new processes trying to take advantage of kind of newer industry best practices, and additionally some of the solutions to those problems. So what I want to do is I want to start by giving my own goal for this presentation, and then we'll talk a little bit about the agenda. That'll be very quick because of course we're going to go over it anyway. So about 4 years ago we started this reboot, and this is my fifth Dreamforce, came to Dreamforce to try to understand whether Force.com platform as a service could play a role. And we decided that it could, and basically this presentation is the one that, at least from my perspective, I was looking for the next 2 years, 3 years that I came to Dreamforce, because we were constantly uncovering challenges in terms of how you can do distributed team development, integrate with source code management, automate builds around this, things like that. And there were certainly pieces of it that we were able to find with companies like Financial Force, who did some great presentations. But I really couldn't find kind of a holistic overview of challenges and solutions. And so in the end, my goal is that someone in this room walks away with the ability to skip at least part of this discovery process. I can't guarantee that our solutions are the best. In fact, there probably are better ones out there. I think as one of the best outcomes of this for me would be if somebody else says, hey, there's a better way to do that during the session, and then we can certainly talk about that. But I do think we've come up with a pretty good set of solutions to these problems. So what I'd like to do first, and we'll do this in just a moment, but I'd like to just get an idea of the folks in the audience, how you use Force.com, or if you use Force.com. And then I'm just going to give, at a very high level, a definition of Application Lifecycle Management, and then what will be the primary focus of this presentation will be a subset of that. That'll be the software development lifecycle. Then what I want to do is just to provide context for the problems that we face, is just give you a high-level overview of our application topology and its use of Force.com, and then the way that we apply ALM and SDLC to that. And then we'll get into the meat of the presentation. I really want to just talk about the challenges, and the challenges at each phase of mostly the software development lifecycle. And then we'll talk about the solutions to those challenges. And there won't be a solution for every challenge. And so then I want to do is I want to list the remaining challenges and pretty much what my wish list would be for how those challenges will be overcome. And then we'll move into Q&A. Okay? So let's start with the audience composition. So does anyone in here distribute software using managed packages? I know you guys do. So no one uses managed packages? And then the next ones are actually going to be pretty quick, but that's good because hopefully you're going to get the most out of this presentation. So we actually also distribute more than one managed package, and there definitely are challenges to that, and we do that using code sharing. If you've come from a background in other software engineering ecosystems, Java, .NET, C++, whatever it happens to be, you know that you can typically just go and build libraries and then build on those libraries. And there's an analogous mechanism in Salesforce, but it definitely presents its own set of challenges. And let me just ask this: who in here is plans to build managed packages and distribute software using managed packages? No one? Maybe? It's always possible. So one of the questions here is native versus composite applications. A native application is 100% in Force. A composite application basically engages a Force.com based application with some external system. Ours is a composite application, backend hosted in AWS. Does anyone in here use source code management? Yeah, good to see that. And does anyone in here use some form of an automated build? Okay. Now, I know the answer to this. I'll raise my own hand. But if you're not doing managed packages, you don't do all this. Okay, so just at a high level, I don't want to spend too much time here, but application lifecycle management basically begins with an idea. There's something that you or someone thinks is a marketable concept and wants to go out and build software to solve that problem. And so the first thing that happens is there are basically three major aspects of application lifecycle management. The governance aspect is really the beginning of it. It's the business problem that needs to be solved. It's not just the requirements. It's not just the statement of the problem and the requirements that fall out of that, but it's also, what's the cost-benefit analysis of that problem? What's the market analysis, competitive landscape, things like that, so you understand it hopefully reasonably well before you dive into it. Once you understand it, then you move into the development aspect of ALM, which is really what I'm going to focus on in here. But this is take those business requirements, the what, and translate that into the how, implementation details, things like that. Then once you've constructed some amount of software, that's not inherently deliverable, so you have to build it, you have to package it. And then, obviously, in a perfect world, you're going to test it as well, make sure that it's in a deliverable state. And along the way, you're going to raise tasks, you're going to raise issues, so some type of bug tracking system, things like that. Even outside of that, you need to understand the overall evolution of the software over time, change control, changes that come in from unexpected sources, changes that come in from new feature enhancements, but you have to at least understand how your product evolves over time. And the third major aspect is once you have released the software, you have delivered it, you put it into an operational environment. In traditional desktop software, that operational environment is somebody's desktop. But because we're talking about software as a service, that operational environment is a data center somewhere. Salesforce likes to say no software, but what they mean is you don't have to install the software. There's a whole host of data centers out there that are running that. And even with managed packages, you're effectively deploying that application into their topology to be used by your customers. And then once it gets into operations, you're really talking about not just the deployment, but just the real-world life cycle of that. How do you support it? How do you monitor it for performance issues, things like that? And then it really becomes a cycle, right? At that point, you get new requirements that come out of, you now have customers hands-on with the application. You're going to get feedback from those customers. You're going to get additional feedback from outside, from market conditions, from changes in competitive landscape, from new technologies that have been introduced, and you need to go keep up with it. But the application lifecycle management is not eternal. That cycle is not eternal. At some point, every product reaches its end of life, and there's a variety of reasons that can happen. It may be replaced by another product. It may no longer be relevant in the market, but that's really the full end-to-end on application lifecycle management. Now, for the purposes of this presentation, I plan to focus on the development aspect of this, because while there are certainly challenges in the other two aspects with Force.com Platform as a Service, the majority that, at least in our experience, you'll run into will be during development. Okay, so a high-level overview of our application topology. I'm not going to go into detail about our applications themselves. Like I said, it's a hybrid application. What we call the system of engagement resides in Force. This is the glass. This is where users interact with the system. Administrative users, end users, whatever it happens to be. They configure the application. They run long-running operations. Ours is a data processing system. So they're on the back end. That's actually where the customer-provided data lives. That's where our large-scale data processing engines live. We host that in Amazon Web Services, and we integrate the two securely using a digitally signed, if you've heard the term HMAC, but hash-based message authentication code. We use digitally signed web services bidirectionally in order to do effectively a secure single sign-on. The thing I want you to concentrate on, though, for those of you that are at least familiar with managed packages, is we actually distribute 5 managed packages. The bottom is not one that we wrote. It's actually a fantastic third-party library out there that is, for all practical purposes, a port of one of the Apache Commons Java libraries to Apex by a gentleman named Richard Van Hook. With his permission, we repackaged that, and we now have lifecycle control over that because we may need to have bug fixes, things like that, and he's constantly evolving his. And so he gave us permission to have our own, basically version-fixed distribution of it. The next tier up, the red box, is our common set of services, custom objects, custom fields, Apex classes, Visual Force pages, things like that, in support of all of our other applications. And this is what I meant by effectively a shared library. It's what's called a base package, and then the packages that build on it are our applications. Margin Max is our price optimization software. Sales Max is our opportunity optimization software. And then Sales Max Connect is an extension of Sales Max that integrates that opportunity optimization, that business intelligence, into Salesforce CRM, Sales Cloud CRM. This tiering of managed packages is really the major complicating factor in doing development with Force.com. And so we'll talk about some of the reasons why. Now, one other thing I want to give is some insight into the way that we approach ALM, and to a large extent, this existed before we incorporated Force. Obviously, Force extended this notion. Every developer, and not just developers, really every individual contributor has a full end-to-end development environment. And this is important. We don't collaborate on a single Force.com org. We don't try to spin off sandboxes from it as our way of giving people individual places to work. We actually go out and get partner developer orgs. Every developer has a local web container. Tomcat is what we use. Every developer has a local database, so we have isolation. We use source code management, a source code management system basically is the backbone for coordination of those resources across developers and really across all of our environments, but everybody has their own isolated environment. From a testing standpoint, we try to apply something akin to industry best practices, separation of concerns. Unit tests basically test units of execution but don't touch externals. Component tests test component coupling but don't require an entire environment to be built up. Basically, good input, good output, bad input, it's handled properly. So if you go and try to save something in the database, you make sure that it got saved to the database from, say, the business logic layer. But there's no need to go build out an entire environment, an entire topology. Functional tests execute within an entire topology, and they include everything from Force all the way down to the database. They include the web services tier, the business logic layer, and they effectively simulate end-to-end use cases and make sure those end-to-end use cases execute up and down the stack properly. And then upgrade tests. Once you start getting into a software as a service realm and you get to a point where you can be agile and you want to release frequently and things like that, you want to be able to make sure that you can upgrade what's out there at any given time. So we are constantly sanity checking ourselves. You introduce a new feature, it needs to have an upgrade aspect associated with it if it changes the running system. We use Perforce for source code management. We're looking at Git right now as kind of a pilot project. It really doesn't matter what you use. It's just important that you have some way of being able to have an audit trail and even a way to backtrack on the software that you produce. Our branching strategy, one of the wonderful things about software as a service is relative to the old enterprise model. The old enterprise model, you worried about versions that dated back as far as 3-4 years. You're going back and patching them for customers that have that. Software as a service, at least for us, and this is a slight exaggeration on it, but you worry about 2 versions, the one that is in production and the next one that's going into production. And so that's really nice. So our matrix of branches is effectively, what are the products that we can release independently, and what phase are they in? Are they kind of in an ongoing development phase? Are they in a hardening release candidate phase, so they're feature complete and all we're doing is trying to get ready for release, or are they released? And what we have in our release branch is what's in production. The only additional check-ins that go in that don't come through that life cycle are hot fixes. They're not actually new features or anything. And from a build standpoint, from an automation standpoint, we use Ant and Ivy for our build and dependency management, respectively. We've looked at Maven, things like that, but obviously Ant works really well with some of the tools provided by Salesforce, like the Force.com migration tool. We use Jenkins for our build automation tool. All right, so let's get to the interesting part. So what are some of the challenges that we found that when we started incorporating Force.com into our overall processes? So one of the big ones is namespaces. And since it sounds like at least some people in here may not be familiar with this, let me just elaborate. So when you want to produce a managed package, what you do is you go get a dev org from Force. And you register that dev org for all practical purposes, universally unique namespace. It's just an identifier that becomes a prefix on all the things that get published out of that org. But like I said, it is unique to that org and is unique across all of Salesforce.com. Well, that becomes interesting because, as I said, our developers and our ICs, we distribute our development across a lot of orgs. So we have to have a way, and each of those orgs has some unique namespace. Our convention is some mangling of initials plus the official namespace. So SDWZPF is my dev org. Additionally, in that release candidate stack, we just prefix with RC, release candidate ZPF. So in this case, we need to have some way for everyone, not just developers, but automated build environments, things like that, to have their own unique set of namespaces. But we don't want that to be an onus on the developers as they're going through and doing day-to-day development. So we want that to be as transparent as possible, not just developers, but automated build systems. Multiple managed packages. There's really 2 ways you can do this. You can either simulate the way that you're going to package the software for official distribution, which is you can put the metadata for each package into a packaging org with its own namespace for that package, and basically start building things up like you're going to do when you ship. That's certainly one of the pros is that accurately models your final packaging. It's as close as you can get to your final packaging. We tried that at first. It's extremely painful because cycle times when you make changes are long. You go make a base package change, and then you have to go and upload a new version. You have to deploy the metadata, upload a new version of that. If you want to go put it into another environment, you have to strip that environment all the way down to the metal. Then you have to build it back up by installing that new version of the base package, deploy extension package metadata. We were looking at 10 to 15-minute cycle times to be able to realize a vertical change. So that's pretty painful, but it does accurately model the final packaging. The other problem, and I'll get more into this a little bit later, is that we found it to be unreliable because there were gaps in APIs you could use to automate this process. Now, a lot of those have been filled in. You can now install managed packages, uninstall managed packages, upgrade managed packages using an API. You can't upload, and that's a pretty key aspect of this. We've kind of worked around that. We have something that works, but it means that you're depending on a workaround for what should be a 100% reliable system. So the second option is to figure out some way to take all this metadata and simulate multiple managed packages in a single org. And this is actually what we do, but it comes with its own set of challenges. So on the positive side, extremely fast turnaround times. You basically just go save all your metadata to one org, you test it all out. It really doesn't matter what managed package that's in. That, however, is part of the rub, is there are certain restrictions when you start packaging things. There are certain restrictions that are put in place. For example, only a certain subset of the symbols, basically your methods, classes, whatever it happens to be, your Visualforce components, only a certain subset of those symbols are available from outside that managed package and extension managed packages. And all of a sudden, because you're flattening your namespace, you could go and cheat. You could go and reference symbols from an extension package that you shouldn't be able to. You can go and do things that don't work in production, and I'll give you an example. We have found behaviors where when you cross managed package boundaries at runtime, true managed package boundaries, some of the extension package metadata is lost as it's processed by the base managed package. It's kind of difficult to characterize. We have several tickets open with support, but effectively it gets stripped down to a raw S object instead of having all the metadata about your full extended custom object. That doesn't happen when you're in a single org. So you don't think you have a bug, and then you go and package it, and all of a sudden things behave differently. And then one of the other thing is, and who in here has struggled with governor limits during development? Anyone? Okay. If you haven't, you will. I'll just say that. But it's a necessary evil. It is a very necessary evil. But one of the things you get with managed packages is each managed package, so there are per request limits and there are rolling 24-hour limits. So for the per request limits, which is basically request and transaction, database transaction are effectively synonymous here, each managed package gets its own set of per request limits. So like 100 SOQL queries can be executed. So when we've got that stack of 3 different managed packages or 4 different managed packages, while you don't get even distribution depending upon your business logic, each one has at least available to it 100 SOQL queries. You go flatten this out, and guess what? Your entire top to bottom process is now limited by this least common denominator of 100 SOQL queries. This is one of the ones that we wrestle with all the time, because we're basically having to, like in unit tests and things like that, you're trying to construct an environment to actually go test an interesting piece of logic, and in the construction of that, you find that you're struggling to get everything to work bootstrapping in 100 SOQL queries. And that wouldn't happen in production, because each managed package would have its own set. So those are the main development challenges. From a testing standpoint, I'll just say this. The security model in Force.com is, trying to figure out the right word. I was about to say robust. It is. It's fairly complex. It has a lot of different axes. You have org-wide sharing defaults on each custom object or each object. You have profiles. You have profile settings. Those are different. Those get packaged and can be applied to profiles and correlated with them. You have permission sets. You have field level security. You have sharing rules. You need to figure out how each one of these contributes to your application security model. If you don't test that, when you go and put your product into actual customer environments, it's going to be wrong, guaranteed. So one of the biggest challenges is making sure that as you're developing, as you're testing, as you're building, that you're doing that in a way that exercises whatever your desired security model is. And because of the complexity of the authorization model, this can be pretty tricky. Test scenarios, I'm going to use one in particular. There are some test scenarios you simply cannot exercise during normal development. So there's a feature when you're doing managed package development. It's a wonderful feature called push upgrade. It allows you to take your software and in one fell swoop push it out to all of your subscribers. That is great. In order to keep things secure when that happens, they would not want any logic that executes during that upgrade to run as, for example, a system administrator customer org. Because you could go out and start reaching outside the boundaries of your managed package and doing things you shouldn't be able to do, even if it was unintentional. So what they do is they have this transient special system user that they put into the org while push upgrade executes. It goes and puts any new metadata into place, updates metadata. There's a post-install script that can run an Apex script called the install handler. It runs that for upgrade mode, and anything that happens there is run as a special system user, and then that special system user is gone. And so you end up with these dangling references on some of your lifecycle metadata that points at that user that's not there. Now, in general, it's not supposed to cause problems. We have actually had upgrades fail when you go and do it this way because things don't have authorization. Basically, our running processes don't have authorization to contents of our package when they should. If you go do the exact same upgrade by clicking through the UI and installing a system administrator, the problem doesn't exist. There are workarounds to it, but you can't even test this because push upgrade is only enabled in orgs that have passed security review, your official orgs. And unless you're a glutton for punishment, you're not going to take your test orgs through security review. User interface testing, this is more of a philosophical thing. I think that my experience in the past doing user interface testing, HTML apps, Java Swing apps, Windows apps, is that they're fragile. You're always chasing them. Selenium is the primary toolkit that gets applied, the primary framework that gets applied to user interface testing in Force in our experience. We've used it. What we found is that they're fragile for a variety of reasons. Even using flexible selectors to find elements and interact with elements, sometimes it's just not where you expect it to be if people refactor the page content because they don't go and update the test properly, they don't run the test or whatever. Because we reside in a Force.com ecosystem, if you leave the Force chroming on, the header, the nav bar, the styles, things like that, and they go do an upgrade and they change that, and you don't have flexible selectors, you can break. One of the biggest issues that we have is timing sensitivity. Ajax is inherently, HTML5 is inherently an asynchronous model. And so if you're waiting for something to happen and you're in this multi-tenant environment where it's resource constrained and they're constantly balancing things, there's no guarantee on timing. And so you need to make sure that you're resilient to timing. And then the third bullet, intermittent behavior in Force.com, you can turn this off, but schedule maintenance notifications. When we first started going out and trying to do this, all of a sudden they would pop up a schedule maintenance notification after login and all of our tests would break. So you go to the org and you turn that off. But the point is not everything's under your control. Version control challenges. Didn't mean to jump too far ahead there. One of the big things when you're publishing managed packages is once you hit that release and you hit upload, you are locked into a backward compatibility contract. This is for your customers and Salesforce's customers. Again, it's a good thing, it's a necessary evil. All of a sudden, you have people going out and using REST services, SOAP services that are automatically generated, talking to global Apex classes, and if you just go and upgrade your software and get rid of an Apex symbol or change its behavior or get rid of a custom field, you could break the subscribers. And Salesforce doesn't want you to do that. In fact, that's why they go run all your unit tests as part of their upgrades and things like that. So they lock you in. Well, one of the issues is when you've got a team of developers working, you don't want each of them to have released managed packages in their dev orgs because things get a little bit more difficult than they need to be. But that means that they're not under kind of a constant checks and balances as they're developing in terms of whether they are adhering to what you've previously published. And it may even just be that they don't know if a global symbol has never been published before and they have license to go and refactor it, or if it has been published. And you don't see that until you go deploy this against some place, even for with check only, you go deploy it against some place where you've published you've released that managed package. There's no distinction between internal and external. As an ISV, you see that we have these layered managed packages. 95% of our, what we call published API is for our own internal consumption. It's not something we expect customers to call into, but because of these constraints, we have no capability to evolve that. Well, we have limited capabilities. It's actually getting better. But the point is I would love to see a separation between internal published symbols that we can go, they're mutable, and we control both sides of it, the producer and the consumer, and external that basically are under all these restrictions. Dirty diffs. If you've ever created two dev orgs at different times, different API levels, and then you go and deploy metadata and you retrieve that metadata, you may notice the exact same metadata comes back looking different. Now, this has gotten better over time, but you may see elements alphabetized in one in your XML files and not in another. You may see elements like track trending or default actions for visual force pages, for custom objects, things like that, in one and not the other. And what happens is when you try to go figure out what's changed, it's hard to sort out the signal from the noise. It's hard to figure out what are your intentional changes that represent your features and what is just noise from going and syncing the metadata down. And when you do go to publish, if you have left anything behind and it's something you can't remove, custom objects, custom fields, global apex symbols and things like that, but you actually have left it behind, it's still there. You can take it out of your source code tree. It's actually still there. And again, this kind of falls under the, how do you sort the wheat from chaff, right? How do you figure out what you're really trying to put into customer environments versus what you've left behind? And really here it becomes a tribal knowledge thing. There are probably two of us in our engineering organization that have fought this battle all along the way and now know we can go, yep, those things, we don't even need to look at them. We can just ignore those, and these are the material changes for this release. From a build standpoint, when you upload a managed package, you can upload it in one of two forms, beta or released. If you go released, you get locked in on all those backward compatibility considerations. If you do it as a beta, you don't get locked in, which is great, but you get a whole other set of restrictions. One of them is, if our base package is in a beta form, we cannot upload anything that extends it, period. Again, it all makes sense. What you've done is you've basically created a version of a package that by clicking beta, you've said, I give myself license to go and make backward compatible changes to this. So Salesforce doesn't want you to go and have somebody lock in on that contract because it's not a fixed contract. But this means that we can't go and take that package hierarchy that I showed you, and we can't actually go and model that in end-to-end beta form. We cannot do it. We can only get that bottom tier modeled as a beta package. We can deploy our metadata against it, but we can't, and kind of test it that way, but part of it's not in a package form. And the other thing is you can't upgrade a beta managed package in place. This goes back to that process when I was talking about the two different options for doing multi-package development. One of them was you're developing exactly like you're going to deploy your product into customer environments with multiple managed packages. Well, if you're doing this and you don't want to lock in those contracts, you want each of those to be betas. Well, if you don't want to have to do that whole down to the metal, uninstall the beta managed package, install the latest beta managed package, you'd want to be able to upgrade in place, but you can't. And it's for the same reason. You're not guaranteed that you haven't made incompatible changes. There are packaging API limitations. I already discussed this. Uninstall and upgrade are available through the API, but upload is not, deprecate's not. Deprecate, I'm not concerned with. Upload would be wonderful. And then governor limits. I mentioned earlier there are two types of governor limits that come into play. There's the per request and there's the rolling 24-hour. Here I'm talking about the rolling 24-hour governor limits. We use basically a continuous integration mechanism where we are just spinning builds really every time check-ins go in and everything settles. You wait for a couple of check-ins and then we go and spin a build up and make sure that everything looks good. Well, if you're doing this against Force and you're using dev orgs out there and you're going and undeploying all the metadata, deploying the new metadata, running all the tests, running functional tests against it, that burns through total API request limits. If you're doing that all throughout the day, and you're even in a partner dev org, which is 10,000 total requests, it used to be 10,000, it's actually been raised. It was 10,000, we were running out of them during heavy development periods like, when you're trying to, that last push for release, we were running out of them halfway through the day, and then you're dead until that gets reset. So, that's a little bit of a concern. Several ways to manage that one. All right, so let's look at solutions. All right. So as far as the core of what we did here, we took the ForceCom migration tool, the Ant tools, and the metadata API and the partner API, and we constructed a set of higher level tools that we base everything on. And they represent the primary operations that you would do if you were trying to do full life cycle on your software in Force. So certainly you need to deploy, you need to save. And for convenience, we have full save to server, take everything that's in this metadata package and put it out there. But for ongoing development, we have an incremental save to server. It basically takes things where the mod times have been updated and does a kind of poor man's dependency management, looking for other references and other files to those based on their type, puts those together and just deploys those. And so that gives us pretty fast turnaround time. We're going to do a demo in just a second on what this looks like. and then synchronize with server. If you've used the Force.com IDE and you've used the Team Sync integration, then you know that you can go out and try to reconcile what's in your local file system, which should be what's in your source code management repository, or at least an evolution of it, and what's in your org, and figure out what needs to come down that was modeled in the org, what needs to go up that's in your local file system, things like that. This pretty much gives you the same thing. We pull down the metadata, we do some manipulation of it to make it closer to what we need locally, and that means like namespace substitution, things like that. We sort it out according to managed packages if you're doing single org development, and then we open a diff tool and we show the actual comparison against what's in your local file system. Delete metadata, this is basically our ant make clean for a dev org. Financial Force has one of these as well. They give it away. It's out on, I think, financialforce.github.com or something like that. Ours, we already had it when I found out they had it. It does a few things that, at least at the time, theirs didn't do, like it peels back the layers, like it unassigns permission sets from users so that they can be uninstalled, things like that. But it's effectively the equivalent of going out and saying, scorch the earth in my org, I need to start all over. And then package manipulation utilities, and then permission set utilities. Permission sets are our declarative authorization model, our packaged authorization model. We use them very heavily. But permission set metadata is very explicit in the contents. It wants to know the exact classes, the exact fields, the exact whatever is being granted each permission set, and that is obviously constantly in flux as you're going through a development process. It's constantly evolving. So what we did is we built just a very, very small layer on top of it that looks at our metadata and allows you to whitelist, blacklist, and wildcard in order to go build up the most accurate and current version of the permission set that needs to be packaged. As each of these executes, like I said, they translate between the official namespace, which is what we check into our source code management system, and the namespaces in the local environment, you know, basically the developer namespace or the release candidate namespace or the build environment namespace or whatever. So on save, that's really easy. It's basically, if you're doing multi-org, it's a one-to-one replace. If you're doing single org, it's a many-to-one kind of collapse. The sync tool's more complex because you have to, especially in single org where you've got multiple managed packages, you have to figure out how to reverse engineer that. We figured that out pretty well. It's not 100% perfect, but it uses a heuristic to go and figure it out based upon the unique symbols. When we're doing single org dev, we actually have multiple unmanaged packages in that org, and again, I'll show this in just a moment. We have multiple unmanaged packages and one per managed package that we want to develop. So in that stack you saw, there's an entry for each one of those. Realistically, there's one managed package as well, and it's that base package, our platform package. Now, one of the side effects of being able to do all this, because you're deploying, is you have to have uniqueness across of symbol names. Apex classes, top-level symbol names. Apex classes, custom objects, Visual Force pages. You have to have uniqueness across all of your managed packages. So 99% of the time, it's not an issue, but if you end up having like an Apex class that has the same name, then what we do is just prefix it. Platform configuration controller versus margin max configuration controller. But they have to be unique, otherwise, last writer is going to win. So one of the nice side effects of this is it allowed us to pretty much use whatever tools we want. We now have command line tools that can pretty much do all of the lifecycle operations that you would be doing elsewhere. Otherwise you're primarily looking at the Force.com IDE, or you're looking at something like Maven's Mate, things like that. But like I use IntelliJ IDEA, we've got people that use VI, Emacs, Sublime Text, diff tools, Beyond Compare, or Axis Merge, and if those tools support external tools integration, you can pretty much make it seamless. It's pretty nice. Now it's not a full-blown IDE, don't get me wrong, but at least you can use something you're very familiar with. So let's take a look at this. Getting a little bit low on time, so let's show it. Okay, so this is my IDE, and I just put a really simple little class together. And the things that I want to show here are some of the things that it takes care of for you, even though you're in multi-org. I'm sorry, single org. So this is technically in an extension package, and it's referring to a symbol that's in the base package. And in a managed package environment, you would need to qualify that with the namespace of the base package. But one thing I want to show is we've done that here. We have not done that here. Because we're going to be deploying all this metadata into the same org, that's actually going to be OK, but that's not going to be OK later. So we don't want that to continue to be the case. Similar down here with custom objects. I didn't qualify this base package custom object with its namespace. I qualify one of its fields, but it's inconsistent. And so what we can do here, because of our, I'm going to make sure there's a change here so it saves because of our incremental save. And this is what I meant by the external tools integration is now I'm going to go do this. Now, there's an ant target running, save. That's our incremental save. It saw that there were no changes to platform, so it started at the base package, no changes there. It saw that there were changes to margin max. You see there are 7 files, a modified 1. Well, it has to send the meta XML file with that as well. It has to send a package XML. There are a couple of other files that it has to send as well. So it's going to deploy all those. But you notice it's sending the bare minimum that it needs to in order for this to go over fine. And as soon as that gets done, what we're going to do, all right, so 28 seconds. And so now what we'll do is we'll go over to the developer console and take a look at what it did. All right, so let me close this guy up and I'll reopen it. There we go. Kind of hard to do this looking over there. All right. So as I mentioned earlier, my org's namespace is SCW ZPF. So it went and did a translation as it saved to make sure that, because otherwise it would not have actually saved. It would have said that it can't resolve ZPF dot. So it did that, but it's still allowing these unqualified, but when I take this out and try to put it into a multi-org environment, that's just not going to work. It's going to blow up and say that there's no class called logger in my margin max metadata. And so now let's go look at what happens if we do a sync. Now, one thing I'm going to mention here is that sync earlier today, just the retrieve metadata was running a little bit slow because we have limited time. One of the things that I want to do here is we have a debug mode on this. You'll see it'll actually say using a debug copy of the metadata. So it's going to go really quick and it's going to go into a compare tool. And let me move the compare tool onto that screen. Okay, so this is platform. It's saying that there are no changes in platform. So there's nothing to do here. This is beyond compare. This, one of the options. Now it's going to do the margin max metadata. So one of the things it's going to tell you is there's a set of symbols that are ambiguous. These fields, objects, whatever, they exist in both. Now, like I said, they have to be unambiguous at the root level, at the root level. But we have an object called, for example, logical entity. Lookups on that are also called logical entity. We have a field called position, and several of our objects have that field. So it's saying that it cannot unambiguously restore namespaces on these symbols. So when you go look at the diff, you just need to be careful and make sure those are right. So now let's take a look. And so now it's saying that there were changes in this file when it was downloaded. And let's see what those changes are. So the left is what it pulled down and then basically manipulated from force. The right is what I have right now that I deployed. Notice that it added a proper qualification on the right-hand side of the assignment, and similar down here. So it put these in good shape for us to be able to put these now into a multi-org environment. And all I need to do is go over here and say, yeah, I want to accept these. Now, the other thing that it did, backing out of here, is the meta XML. It recognized, because force doesn't see package dependency in the meta XML because everything's deployed locally, it recognized there's a package dependency because there are references to things in ZPF, and it added it. This probably isn't that important, but at least keeps things consistent. Okay. So let's go back over to here. All right. Starting to run out of time, and by the way, I'll be very happy to continue to talk about this after. I know there's a lot of content. But as far as the security model, the big thing is bake authorization requirements into your core business requirements. Have your product managers think about this and declare it very, very explicitly. And then that story doesn't close until you validated it, until it's implemented and it's validated. That's just a process change. Minimize the differences between the way that you build and the way that you deploy. Make sure you're not doing everything as system administrator anywhere. This is core, because otherwise you don't discover things until, frankly, too late. As far as the test scenarios, the one where with push upgrade, Salesforce support's great. We call them, explain the situation to us. They actually, even though it hadn't passed security review, they enabled push upgrade in our release candidate org, so now we can actually test it. You can't ask them to put it everywhere, but be a little bit selective about that. And as far as user interface testing, we actually audited all of our Selenium tests and categorized them as functional or behavioral. Do they require the user interface, or are they just exercising a workflow that you could do through an API? And for the ones that were functional, we refactored those to actually not use Selenium, but instead be Apex functional tests. They became extremely stable. And for the remaining ones, we went and audited, what's the value we're getting from these UI tests versus the cost that we have of keeping them healthy? From a version control standpoint, I mentioned this earlier, just make sure you're deploying against a previously released version with check only. So what we do is every time we release, we go do a single org packaging of each of our products so that we have everything in place. And then we basically deploy our metadata against that with check only, and it tells us if the last check-in has made a change that would not be allowed when we go to actually release our product. So we get a very fast feedback mechanism on that. As far as dirty diffs, this is a process change. Basically what we do is require that all check-ins of metadata be, this kind of best way to put it is, be laundered through Force. Save it to Force, retrieve it, and as you just saw, it's going to go and organize it the way it wants. And since they've made that more consistent, now we're all going to have consistency if we all follow this best practice. As far as what we do when we publish our managed packages, we've effectively gone through, I'm just going to skip a little bit ahead, we've gone through the best practices for each type of metadata and what we can do with it. And so the big things are global Apex classes, methods, fields, and custom object field and display names and permission sets. On those, basically we have to leave them. If it's for internal use only, we go and gut, for example, a method. We gut the method. We have it throw in a legal state exception from Apex Lang, and similar to what you do in Java with unsupported operation exception, if it's for customer consumption, we really can't get rid of it. And then for fields and such, we go and for permission sets as well, we basically go and mark them as deprecated, label them as such to get them out of the way. And then, for example, with permission sets, we replace it with one that's correct. The general reason you do this is you overgrant. You can't take, there are no takebacks with permission sets. If you publish one and you've overgranted a permission, it's there. So if that doesn't adhere to your restrictive security model, you need to clone that permission set, strip out the permissions that you don't want, and make that your one of record now. And so what we do is do exactly that. We swap the new one in, and then during our upgrade, we automatically migrate users that have the old permission set to the new permission set. And we take anything that we actually take out of our SCM so that we no longer have to have ownership of that. Build solutions, we use single org deployment for fast, reliable builds. We use a lower frequency multi-org deployment just to validate cross-package boundaries. Yes? I'll tell you what, let me finish this real quick, and we'll do a couple of questions if you don't mind. Packaging API limitations. Single org doesn't use the packaging API. You just use the metadata API to deploy. Multi-org builds use it. The only place that we've had to work around is upload, as I mentioned. And what we did is we basically built a CLI that does it by crawling the setup UI to click through to do an upload. And luckily that UI stabilized, and now that's a nice stable target. And as far as governor limits, we called support again, said, hey, we're having a problem here, we can't get through a day, and they went ahead and raised the total request limits in those orgs from 10,000 to 25,000. We have no problem getting through a day. Those have been raised through the tooling API to 15,000 anyway now. I added this earlier today because it popped into my head. One of our big process changes, you go through security review once a year, maybe a little less frequently. But every time we release, we basically make ourselves go through the process of at least understanding where we are so that we're not caught by surprise at the end. So we review these security vulnerability reports, and we treat any reported vulnerabilities that we actually consider to be worthwhile, that are real, that are not false positives. We review those, and we make those must fix for the release. And as far as the wish list, packaging automation is still fragile, but you know what? They're finishing that. We actually talked to the PM for packaging yesterday, and that's on their roadmap. Multiple managed packages is still difficult. I would love to be able to do this in a single org for real, where they're all treated like real managed packages. It's probably not the way they're going to do it, but I'd love that. Evolution of managed packages, actually they've got their managed package flexibility now that you can use. And right now, you're in the middle of Winter 15 upgrade. Our packaging orgs have already been upgraded. All of our subscriber orgs haven't. Guess what? We can't push out a hotfix, because you can't push out something that's in Winter 15 to somebody that just has Summer 14. So we talked about this yesterday too. What they're probably going to do is make it so that packaging orgs get moved into an instance that is the very last one upgraded to make sure that throughout this window you can always still create a package that can go into all subscriber orgs. Whew. Okay, so there we are. Now, do we have time for questions, or are we getting kicked out? You do? Okay. I'll tell you what, let me step outside, and I'll be happy to answer any questions that you have. So thank you very much.